Hello, another chapter of TRIZ, a part of classical TRIZ contradiction analysis. That was also a gift of Henry Altschuler and a part of TRIZ he introduced back in 50s of last century. The idea of contradiction analysis and advantage of contradiction analysis is that you start observing, you start modeling of any real product, technology or process as a combination of contradiction. The message of Altschuler was that eliminating contradiction, you are improving system. Another very nice observation of Altschuler was that among all, let's say, inventions, there are inventions that eliminate contradictions and they should be called real inventions, and all other inventions. So contradiction analysis, finding of contradictions and eliminating of contradictions is the key for classical TRIZ. So we believe that eliminating contradictions, we are improving the system and we find a kind of out-of-box solution or find an invention. There are two types of contradictions. Altschuler recommended to start with analysis of engineering contradictions, a situation when you try to improve one part of parameter of a system and when another parameter or a part of system worsens. And then if you analyze more, then you arrive at a physical contradictions, a kind of screaming contradictions, situation in which you have a kind of justified requirements to opposite parameters or states of the same parameter. You want something to be long and short, warm and cold, and so on. We are going to go through this method. We are going to do some exercise. We are going to define it. We are going to learn how Altschuler recommended to get rid of contradictions, to introduce, to learn to apply Altschuler metrics, a table of resolving, eliminating of engineering contradictions, and basic general principles of separation principles. So let's go and learn what they are. History of this concept, the concept of contradiction. Of course, I couldn't help driving back to ancient China. Chinese philosophy, yin and yang. There is always something good in something bad, and there is also something bad in something good. So then it would be this concept of yin and yang would serve as a kind of fundamental background of contradiction concept. But coming closer to modern life or to modern school of philosophy, we couldn't help pointing out that the Hegel philosophy and the philosophy of dialectics, the logic of dialectics, was based also on contradiction concept. That is why also some researchers strongly believe that Altschuler was that much influenced by the concept of Hegel, because it was a part of official, let's say, philosophy in Soviet Union time, that he just adapted the concept of contradiction to the analysis of engineering system. So there were two roots, could easily find yin and yang, that is actually like physical contradiction, and the philosophy of Hegel, dialectics, and this part of materialism philosophy. That was. As always, we will try to build some bridges between the concept of contradiction and some chapters inside of TRIZ and outside of TRIZ. So links of this concept to other concepts that people use in order to analyze or to improve product or a process. First, we'll start with the links to other chapters of TRIZ. As I already said, contradiction concept is a fundamental part of TRIZ, actually. The whole TRIZ is based also on contradiction analysis, and that is why these bridges are very strong and very wide. First of all, if we believe the system evolves, then in a kind of way, according to Altschuler principles of technical or engineering system evolution, then evolving from one generation to another generation system gets rid of contradictions. So eliminating contradiction one by one, the system becomes more dynamic, system becomes more functional, system becomes more ideal. Ideally, when the system has reached its final point, it disappears. It does not exist as a as a product, as a material product. And obviously, if it doesn't exist, there are no contradictions, of course, and that is the arrival point. If we try to understand what is happening when system becomes more and more dynamic, more and more adaptive, then definitely dynamicity means flexibility. And so when this way we have to resolve a contradiction, let's say, to have something short and long, so we make it dynamic, flexible, foldable, portable, and that's how system becomes more and more dynamic, resolving a contradiction, resolving a kind of situation when two, let's say, mutually excluding properties are exposed to the same part of a product or a system. What else parts of TRIZ? Yeah, definitely ideal final result, as I already said, because we believe that system is ideal when it doesn't exist, but the function is ensured. If system doesn't exist, there are no contradictions in it. Some contradictions could be found, let's say, when we do functional modeling of a situation and we find that there is some coexistence of a useful function and harmful function. This coexistence could be treated as a contradiction because we need an element to perform some good function, but at the same time or in the same place, the element of technical system generates some harmful, unwanted function. It could be also sort of a contradiction. And finally, in substance field analysis, we also have very often, we can model a situation like we have some useful action and harmful action, and the harmful action should be somehow blocked. So, and this part also could be observed as a kind of contradiction. So definitely, ideal final result, trends of engineering system evolution, substance field analysis, function modeling, all these elements of TRIZ, all these chapters of TRIZ are strongly linked with the concept of contradiction. Regarding some other elements of design outside of TRIZ, I would mention here quality function deployment. I would mention here axiomatic design and the principle of Pareto optimum. If we start with quality function deployment, then, as you know, there is such a thing called house of quality. In this house of quality, first you interpret customer expectation of a quality of product into a specific engineering specification. And then you check what happens if you improve this or that element of engineering specification. What happens if you make system lighter, or what happens if you make system stronger? What happens to other parameters? And then you try to find a kind of correlation between them. That forms that so-called roof of house of quality. So if you have some, well, let's say, positive correlation between some parameters, so that means you try to improve one engineering parameter, but you realize that another parameter worsens. It's nothing but specification. Sorry, nothing but contradiction situation, and that means that you have some contradictions in your design, in your specific design you're analyzing. If we try to revisit axiomatic design, we realize that there is again a matrix, and in this matrix there are design parameters and functional requirements. So the situation when the system the design is not good, well the matrix has a full range. There are everywhere there are some pluses. That means changing one design parameters, you influence, unfortunately, several functional requirements. Could be also treated as a contradiction. So the system with contradiction in the language of axiomatic design would mean that the matrix, so-called SO matrix, is non-diagonal, or even worse, it's called like full rank, or it is like full type of matrix. So the design is not independent as it is stated in axiomatic design. Other links to Pareto optimum. I found that this concept of Pareto optimum exactly as it's a formulation of a status of a system in which if you try to improve one part of a system, another system worsens. In other words, Pareto studied the wealth of a society. And he introduced a kind of concept. He believed that the system, the economic society, is in a kind of balance or it's a kind of optimum. When you try to improve a wealth of one type of people, one class of people, then the wealth of another type of people worsens. And it sounds so familiar to the definition of engineering contradiction of Altshuler. If we improve one parameter of one property or one function of one part of engineering system, then another property of another part of engineering system worsens. So it's one-to-one the situation. If it is possible to improve something without worsening other parameters, that the situation there is no contradiction, or the system is not in Pareto optimum. So you improve it until the point you realize that if you improve more, then other parameter worsens. So these are direct links to the concept of contradiction that is used in other design, let's say, approaches or even analysis approaches. Pareto optimum, axiomatic design, and quality function deployment. What is discussable about contradictions? Because we cannot leave contradictions, the chapter of contradictions, without finding something contradictory in them. First of all, I have to say that, of course, unquestionably a strong tool, but it requires analysis of technical system, of parameters of technical system in pairs. So those who were more comfortable with the kind of system engineering, when first you have to list a specification of parameters of technical systems to be met, it is a bit off. Because in contradiction analysis, it is assumed that you find only a pair, two elements that are in conflict, and then you eliminate them, and then you arrive at another design. And you have to analyze another parameters of technical system, and it's not 100% fair. In this way, I would say that the list of requirements in a form of quality function deployment, house of quality specification, when they're all listed, and then you try to check if they are in contradictions in this type of design or this type of design, is more systematic in a way. And another thing, it is a good thing, and at the same time, like in a physical contradiction, it's a bad thing, that actually in formulation of contradiction, there is a hidden request to know system much deeper, because it is assumed that you already know how to improve the system. Because the formulation is, if I improve the system by making it, I don't know, longer or heavier, then something worsens. So it is assumed that you have to know something, how to improve the system. If we speak of something simple, a pointer, a chair, a flip chart, that is definitely easy to formulate. But when we are talking about a nuclear reactor or some, let's say, professional design, it's not very easy for if you are not in the business to say immediately how to improve, what will improve this parameter or another parameter of technical system. But let me end up with something really positive. So this really very strong and nice tool of analysis. Use contradictions and you will have a lot of inventions. What are the conclusions on this chapter of TRIZ? One of also fundamental chapters of TRIZ, contradiction analysis. Contradiction analysis is a very strong modeling tool and the tool to modify your design. In contradiction analysis, it is assumed that you analyze existing contradictions. First, you find them, you model your product or your process as a kind of contradiction, and then you have to eliminate it. And there are two types of contradictions, it is believed. First type is engineering contradictions. When improving one part of a system, another part of system worsens. And to eliminate this type of contradictions, you can use a recommendation of Altshuler in the form of Altshuler metrics. There are standard contradictions, there are standard methods to eliminate those contradictions. If you analyze the system more, you can always arrive, and you should always arrive in the situation of physical contradiction, in which you have a kind of opposite requirements to the same part of technical system, the same element of technical system. And these contradictions are kind of screaming because you want from the same part of technical system to be big or small, to be warm or cold, to be flexible or hard. To eliminate those types of contradictions, you should use separation principle. This is a very strong principle, and somehow it covers all the principles of Altshuler metrics in a way, because separating the requirements, you eliminate contradictions. There are not anymore a situation in which improvement of one parameter or part wasn't another part. And the most typical way to resolve, to separate, is separation in time and separation in space. I think 94% of successful inventions were about separating in time or separating in space. It's a nice, let's say, methodology. It's simple methodology, and you can start inventing just immediately with this approach. So you have to master a bit your skills of finding contradictions everywhere and interpreting those best practices distilled from Heinrich Altshuler from those 40,000 patents.